if we're going to derive this, it would be a bear when you do u prime over u to do this whole thing as like a chain with a quotient inside. It's so much more easier to do something like this. The cube root is 1/3, and you can then pull that out front. Okay. Now, that's a lot of parentheses. I don't need all those parentheses. But this is a 1/3 power. 1/3 power can jump in front of a log. It's a property of logs. Then, from there, you can also, another property of logs is division is minus. So we could rewrite this now as a 1/3 out front, and we have natural log x minus 1 minus natural log x plus 1. That's how I would do it before I even start. Then, this is an easy derivative. I could take the 1/3, just leave it there. So y prime, leave the 1/3, okay, and the derivative u prime over u, so the derivative of u would just be 1 over x minus 1, u prime over u, minus u, derivative of this is 1 again, over u, and that is your derivative. Now that could be simplified. If I simplified it, I'd multiply this one by the x plus 1. So if we wanted to simplify this, it would be 1/3, and this would be x plus 1 minus x minus 1 all over x minus 1, x plus 1. Again, what I did is I took x plus 1, multiplied the 1 up here, x minus 1 multiplied it there, and when you do that, it looks like your answer for y prime is going to end up as, there's a 3, x minus 1, x plus 1, and on top, that x minus x is gone. Is that a 2? Is that correct? It's like 2's left over on top. So that's looking like the answer. And you could probably change it even more, but yeah. If we wanted to try to find the critical numbers, they would be 1 and 2, 1 and negative 1, and then we got to check to make sure they're possible, but that would be what we're kind of getting at. Now for the equation of a tangent line, for equations of the tangent line, you need x, you need y, which we have, and slope. So to get the tangent, we need the slope at e. To do that, we first have to derive this implicitly. So to derive this implicitly, y squared, when you derive that, is 2y, don't forget y prime. Remember chain rule? A lot of people forget it. Plus, now, this ln, do you understand I can separate it to an ln x and an ln y? Because of the multiply, you can change it to plus. The derivative of ln x, again, this right here could be ln x plus ln y. That can be rewritten as this, which makes life quite a bit easier maybe. Ln x looks like it's going to be, well, the derivative of x is 1 over x. And this one, well, the derivative of y is y prime over y. So this is going to be y prime over y. And the derivative of 2 is 0. So that's my derivative. Now you could get y prime by itself, but that's kind of a waste of time, because what we want is the value of y prime, and you kind of just go and plug these two values in and then crunch it down, meaning if I plug this in for x and this in for y, it looks like I'm going to get 2 times 1 y prime plus 1 over e plus y prime over 1 equals 0. And from that, I can solve this for y prime. It might be easier now than before. Maybe not. It all depends. So this 2y prime plus y prime equals negative 1 over e. Now what I did there is I moved minus this over and kept the y primes over here. And from there, some of you might get confused, but basically, what's 2y prime plus y prime? That would be 3y prime. And from that, you divide by 3. And if you divide both sides by 3, you're going to get y prime equals negative. Won't the 3 go down to the bottom with the e? So negative 1 over 3e. And the bad thing on a test, don't think that's your answer. Isn't it sad how many of you probably would go, that's my answer, good. You forget to go back and see what the question was asking. The equation of a tangent line. Don't do that cardinal kind of dumb mistake. So the equation of the tangent line would be y minus 1 equals negative 1 over 3e x minus e. X, y, and your slope. That's what we're looking for. And if it's a multiple choice test, you might need to change this into the other form, which is slope-intercept.